Let's sketch a scenario where you're standing some distance away from the bottom of a building and your friend is at the top of the building. By what angle would you have to rotate your head to look at them? This angle is what we refer to as the angle of elevation. To identify the angle of elevation, we need to consider the important locations in the scenario. The first location would be your eyes. This is because what changes when you rotate your head is the angle at which you are looking through your eyes in comparison to your straight vision. The second important point are the eyes of your friend. This is because when you look up to see them, you would try to make eye contact with them, which would mean their eyes are what you're directly looking at. The third important location would be the imaginary point where your straight line of vision would meet your friend's line of vision if they were to look 90 degrees down. Let's denote the first point by A, the second by B, and the third by C. Let's connect these points through straight lines. This would construct a triangle, a right angle triangle to be specific. Let's say you were told that the distance between you and point C is 30 meters and the distance between point C and point B is 60 meters. The angle of elevation, as mentioned earlier, is the angle at which you must rotate your head to look at your friend. And that angle in this triangle would be angle BAC. Since this is a right angle triangle, we can use the trigonometric ratios to find this angle. The only values we have of this triangle are the length between A and C and the length between B and C. From the perspective of angle BAC, side AC would be its adjacent side and side BC would be its opposite side. Based on SOHCAHTOA, we know that the ratio with adjacent and opposite is tan. So to find the angle of elevation, we will use the formula tan theta equals to opposite by adjacent, which after substitution would be 60 divided by 30. We can simplify this to tan theta equals to 2. To find the angle of elevation, we will take the tan inverse of 2, which gives us the angle of elevation rounded to the nearest degree as 63 degrees. With this information, we can go ahead and now find the angle of depression. The angle of depression is defined as the angle at which your friend will have to look down to make eye contact with you. To visualize this, let's imagine a straight line emerging from your friend's eyes, which travels a certain distance to point D. A straight line is important because it is what is always used as a point of comparison. The angle of depression would be the angle between line DB and the line AB. So let's mark that angle as angle DBA. There are two ways to find this angle. Let's approach this logically and using our prior knowledge. The first method is to start by finding the angle ABC. The idea is that if we find angle ABC, we can subtract the angle from 90 degrees to find the angle of depression. We subtract from 90 degrees because line BD is a horizontal line, which means BC a vertical line. So the angle in between would be 90 degrees. To find the angle, we will use tan again since we know the opposite side AC and the adjacent side BC. So tan theta would be equal to 30 divided by 60, which can be simplified to 1 by 2. If we did the tan inverse of 1 by 2, we get 27 degrees. 90 minus 27 is 63. 63 degrees is our angle of depression. Now, you might notice that the angle of depression is the same as the angle of elevation. This is no coincidence because the second method I mentioned of is to simply use the angle of elevation as the angle of depression. This works in all scenarios because line DB is parallel to line AC since the distance between the two lines are constant at all points. When looking at the line from this perspective, we know the line AB is a transversal. Recall from your prior knowledge that in parallel lines, the alternate interior angles are equal. So in this case, the angles of BAC and DBA would be alternatively interior, hence equal. So if you find either the angle of elevation or the angle of depression, you know the angle for both. That is it for this video. Subscribe to our channel and thank you so much for watching.